Yeah, I tear my trucks apart all the time. You never know what I might do. I got a shop, I got nothing going on, I got a minor problem, I'm gonna tear something apart. I'm pretty terrible about that. So I got the heat exchanger body ripped off the system. The way I set this truck up, it was unintentional, but I do have to pull the hay filter out of the way because the heat exchanger body doesn't have enough room to come off of the air inlet pipe, which is down inside of it. Of course, I pulled the heat exchanger body out of the middle. This is more or less the exact same design as the Dodge. Essential chamber that is designed for the hot produced gas to flow through it one direction and out into the cooling rails through this flange connection here, and the fresh air coming in through the heat exchanger body, catching all that heat from the produced gas and then shuffling it down into the fire tube assembly as preheated air. Now, because there's superheated gas going through this section, any minor air leak can reach metal melting, destroying temperatures very, very quickly. And I've had a couple leaks, that's why I have it torn apart. I haven't even decided how I'm going to fix it yet. But one of the things I know I'm going to change is this flange is way too close to this barrel. It makes getting a wrench in here to get these bolts out not very fun. There's two of them on the backside. I actually have to go through the back window of the truck with a pair of wrenches and do this, you know, a quarter turn at a time. Annoying. I like things to be much more serviceable than that, so it's one of the things we're going to change. We'll give you a brief overview here and show you the damages that I found. Keep in mind this truck has also been sitting outside in western Washington wintertime weather for about 3 months now. A lot of the time while I was building the Dodge, and once I started driving the Dodge, obviously this thing was parked. Then all the time when I was putting the motor together to go in this truck. So finally time to get this thing fixed and get it back on the road, because this, I'm going to call this truck, even though it's a V8, this is my wood miser. This thing sips the wood instead of burns it like a bonfire like the Dodge does. Let's get a look at what's going on here. First area that I noticed I had a hot leak, you can see the discoloration right here around the bottom of my weld on this crossover flange. Definitely had a leak right in here, gooped it up with silicone. Then the next week I had a little one here, gooped it up with silicone. And this silicone, this is the stuff I was talking about before. This is a Dynaflex. This has been through untold heat cycles. It's still liquid. I do not like this stuff. When it superheats, it tends to actually run out. You can see it on the connection between the hopper and the bottom barrel where it's just kind of glooped out from superheating. Anyways, so I have one leak here that I patched up. Now, when I was cleaning out the hay filter assembly, I noticed I had a leak up on this edge. This is something that every gasifier guy usually has in their roadside tool repair kit, is some aluminum tape for doing HVAC work. This stuff works really good to get you home. So I had tried smearing it with silicone. The silicone fell out. I gooped it on with the tape and that held up. Now that I've torn it out, got a pinhole there, pinhole there, 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 there. Yeah, these drums were not in the best of shape when I first got them. So bottom of this thing is going to have to get completely reconfigured. Two reasons. Obviously it's full of holes and we can't have an air leak in this area because it will hit metal melting temperatures and it will destroy things. I don't want to put all the work into rebuilding this again because it had a hot leak. So we're going to rebuild for that reason. And number two, I had just done a char dump on this truck and I used this 2-inch pipe cap as my clean out port, and you can see how much char was still in there that just would not want to flow through that 2-inch hole. Clean outs on this were a pain in the rear end. The barrel sits so low in the bed, I could take the cap off and I would shove a wire up in there and try and break the char loose, and I would use the pusher blowers running to try and force that char out. A lot of times that didn't work. I would actually hook up a shop vac right here on the cooling rails to help force the char out of there. And of course that's a giant plume of mess, and it's not any fun, and you get black from your head to your toe, blacker than a coal miner's taint, as some guys would say. So I definitely want a clean out port that is easy to open and access so I can clean char out of here, especially because I run so much softwood in my truck. I produce a lot of char and I have to clean it out all the time. So I'm gonna start cutting this thing apart. Probably gonna reuse the flange itself and maybe the top half of the barrel, maybe? I'm not sure. Figure it out as I go. Well, deconstruction's coming along. I got all of the insulation rings pulled out. The other insulation I had in this was corrugated metal roofing, which I cannot believe how much of it has decided it wanted to leave the chat. That is incredible. Wow. Corrosive power of wood gas. I believe that's made much worse when the truck sits. I can feel on the char dust that's in here that there's a lot of moisture. So it's a perfect environment for rust to grow. But we'll have to do something new for insulation and whatever I end up coming up with to fix this. Decided what I want to do. So on a typical wing Keith, this heat exchanger body, this lower area, its really only purpose is for catching all the soot and charcoal that can slip past the grate, and the vacuum of the engine can pull it across, and this little lower area below the pipe coming across, it gives a little bit of a vacuum differential where, granted this is sitting upside down, so just bear with me. As the char is coming across and it comes into this open area, it has a moment where vacuum kind of lets go of it and has a chance to drop. And this is kind of the reserve area where we clean it out from. That's why we call it the drop box. We're planning on most of the charcoal that gets sucked through here and soot to drop down and be stored right here instead of getting sucked up into the cooling rails and into the rest of the system. Wayne calls it a drop box. All right, I can work with that. So I took and cut the bolt flange off of that. So I've got, the same bolt pattern on the lower barrel of the gasifier, and I'm going to build an actual box for this thing to sit on. Basically, I'm going to take this bolt pattern, transfer it onto here. Now, because this is only 14 gauge, it's got some to it, but since I built on the other truck on the Dodge that's sitting outside, I did want this to be a little bit more sturdy than the flange I built on the other truck. So once I transfer the bolt pattern in and drill this in place, I'm going to weld this down so this has got this big, 1/4 inch backing that will hold on to the side of the box. This will get bolted right in place of where the old drop box was. And I'm just going to build a box all the way around it. And basically where the air inlet pipe comes through, I'll basically have from there down to the bottom of the box for charcoal reserve and for that vacuum differential for the char to drop down and be stored, which will work out perfectly. I'll actually have more capacity for char than I did before, which would be nice considering how often I have to clean this truck out. I'll end up with about 10 inches of char, and this is 12 inches wide, and the box I'm building is going to be 14.5 wide this way, and it's 18 inches deep. So I'll have a nice little reserve area down here so I can hold more char. I can go hopefully longer in between cleanouts. But then on top of that, when I build the front of the box, which will actually face back into the bed, I can put a nice big clean out door right here. Then I can just pull the door off when I need to clean. I can even take, I'm hoping, a full-size dustpan, just reach in, scoop all the charcoal out, shut the door back on, quick and easy. On the Dodge build, I built a bolt-down door, and that works totally fine, but it is a little bit annoying having to sit there and take all the bolts out and pull the door off. This one, I'm going to make it basically a quick release, and I'm going to copy a design. I believe it was Jacob North that made it first, but we'll see when we get there. I'll show you guys how I'm going to build that door. But for now, I need to get this box built. Well, there's the mission essential critical part. So there's the old bolt flange, transferred the bolt pattern onto this plate, drilled it through, and I just have a nut and washer on the opposite side. And now I can get it setting up on there, make sure that bolt pattern is going to work, make sure nothing's shifted. So now exactly where it's bolted down right now, pull it out, weld that down in place, and then we can start building the box the rest of the way around it. Not too bad for a self-taught welder. Now we just got to add a whole bunch of sides onto it. Imagine that. You add a couple walls and a bolt flange, it looks like you're actually getting something done. You can see lots of charcoal capacity, nice and free flowing coming around the air inlet pipe. Plenty of room for the heat exchanger and screws on right here. So now I got to build a bottom and a top, figure out how tall the heat exchanger barrel needs to be, cut it off, weld it to the top of this, and then build a clean out door. Quick little tip for you guys. We all know that all the consumables that we use for doing fabrication are expensive. Your flap wheels, your cutting wheels, your wire wheels, you know, they're expensive. They all add up in cost, especially on a big fabrication project like building a gasifier. Well, if you're trying to save a little bit of time and a little bit of money on your materials, you know, I'm using a piece of scrap here. I've wire wheeled one edge all the way around, nice and clean, ready for welding. I do plan on welding this on both sides, but I am not going to wire wheel this edge. When I put the box down, I'm going to weld the inside first, and I'm going to let the extreme heat from the penetration in the weld do all the cleaning on the other side. Then I'll come back with just a wire brush, scuff everything off, and it's pretty well ready to weld. It'll save you a little bit of time. It'll save you a little bit of money, not having to buy these all the time. Oh, and here's another good tip. If you're using wire wheels constantly like I am, cleaning up rusty material, make sure you dig out all the wires out of your clothing before they get into the laundry. It's not any fun for you to find this when you go to the bathroom and get an unpleasant scratch, but your wife will really thank you for not finding them all over in the laundry when she's folding, and you won't have to tear apart the dryer and the washer to get them out of the traps and the filters where they're stuck in everything. Just finished welding the inside. See how everything got nice and hot? That's pretty darn clean. Now I can go ahead and get this outside welded up. One ugly little box. All welded up. I set my earmuffs on fire, but they weren't on my head, so it's okay. Well, this turned into a long video. So bottom side's all boxed in, top and bottom. I've already built a clean out door. It's just a flat piece of plate that'll get a gasket. It does have walls to go to the inside that will protect the gasket. I'm using a drop bar lock with 2 bolts. You'll see that later to pinch the gasket down in place. We already built top half. See straight down through. See the air intake for the gasifier down there. Lots of room for charcoal in the bottom. I do have a lid already built for the top. Both of them are sitting over there drying because I just painted those. I got to make up the gaskets. The top lid, the one right there, there's a bolt on each side that will lock it down in place. It'll also get the same stove rope silicone gasket that the bottom door is getting. Now because I used 14 gauge sheet for this, much heavier duty than the well, I already cut it up. Yeah, there's remnants of it, the old heat exchanger body. So way heavier duty. It's going to soak up a lot more of the heat. It's still going to act like a heat exchanger because that hot gas will be coming up from the bottom, and then it's going to have to get connected to the cooling rack right here, which I got some marks. When this comes back out, I'll put a pipe that goes through, weld that on there. That'll be all good to go. It'll still be able to slide into its bolt flange there, and that one should be in alignment that when it bolts up, it lines that one up. I still need to build a leg off of the bottom that will support this, because this is quite a bit of weight. It's only sitting up right now because I have a 2x4 underneath of it. Anyways, like I was saying, because it's 14 gauge, there's not a lot of bearing surface for a gasket to sit on, so I took some 1/4 inch round bar and went around the whole top edge. So, you know, nice rounded over edge that the stove rope can sit down against, get a good bite on. I'll build gaskets for those tomorrow. I have the stove rope and the silicone. I just need to impregnate the rope with the silicone, get it nice and tacky, shove it into the groove for that one, bolt it down with some cellophane, and then this silicone will cure in place. I can pull the lid off, pull the cellophane out, and then we got a good lid surface to go down. Do the same thing with the bottom. Then once the gas outlet is on there, I need to position the blowers, which are sitting over there. They'll sit somewhere right here on the flat. I did just run into a small issue with my old heat exchanger out of the old one. No longer fits in here. I built this 11 inches wide, and the heat exchanger is 8 inches wide. Well, 7.5 right in there. But see the fitting off of the side? Well, that makes it about 9 3/4 long. So it fits in here perfectly, but when I go to thread it in, that fitting, smack, stop. So I'm going to rebuild the heat exchanger. Got some 5-inch stainless exhaust pipe that was scrap and a whole bunch of 1.5-inch flat stock. I'm going to build a guide around that pipe. It'll look like a spider. It'll drop down inside of that pipe, get welded in place, cap top and bottom, thread a coupler on the bottom, thread a coupler on the side. Then I can drop that in, get threaded in place, position the gas outlet, get that welded on, put the blowers on, put everything back together. It's turning into way bigger of a project than I was anticipating. But we're getting out for a quick and dirty heat exchanger. Piece of 1 3/4 Cyclone fence, boatload of scrap, 1/8 inch flat stock. I have tons and tons of this. Just welded it radially so that my outside diameter, oh, this is a 1 3/4, I think, flat stock. So 1 3/4 on each side, 1 3/4 in the inside, and that's right about the perfect diameter to take this piece of 5-inch exhaust. Bam! Now I'll weld the ends of it into the bottom, weld the ends on the top, then the actual heat exchanger itself is done. Then we just need top and bottom plate, which I got some scrap 14 gauge plate down there, set it in place, weld it around top and bottom so it's capped. Then I'm going to take the old heat exchanger, cut the threaded fittings off, weld the male side on the bottom. I can take this, set it in the heat exchanger housing, figure out where I want my blowers to hook up. Once I decide where that is, I can place that port, set it on here, weld it in place, knock the hole out, cap the bottom, fill it with water. I know it's going to be sealed as long as these two ends and my fittings seal up, and then this is ready to go in place. Good old hot water test. Don't see no leaks. Definitely know we burned it in hot, because I was boiling long enough for me to get the camera out and turn it on. It's still boiling. Already got the male side on down here, welded, water tested, knocked the hole out. Kind of get an idea how all the air obstructions are going to make that air real turbulent in there and dwell time. Now I empty this water out, get that hole punched, put a cap on this thing, and she's ready to go in. And just as Henry Ford said, you can have it any color you want, as long as it's black. Mostly because black paint is cheap, and this is going to get subjected to extreme high temperatures. So we've got our port here that'll hook up our blowers and our shutoff valve. We've got our port here that'll hook onto the cooling rack. The lids are already over there painted up. Just got the first coat of paint on this. Probably give it one more coat at least, and then make up some gaskets. She's ready for assembly. And then, hopefully next video, the old wood burner is going to be back on the road. I mean, the V10's still on the road, but I need to get this one back on the road, something fierce. Might even slap a little paint on the gasifier there. Alright, talk to you guys soon when we get this thing assembled.